All right, today we're going to tackle one of the most critical issues of our time: global climate change. We're going to get into the science, look at the hard evidence, and really understand what's at stake for all of us and for the planet. Let's dive in.
To really get a handle on this huge global story, we're not going to start with a bunch of charts and graphs. Nope. We're going to start with just one really powerful image from way up in the Arctic.
So, the polar bear. It's become the symbol of our changing climate, right? And for a very, very good reason. Their entire existence is built on sea ice. It's their hunting ground, where they catch the seals they need to survive. But as our world gets warmer, that platform is literally melting away right from under them.
And this isn't some abstract idea. You can actually see the impact. Up near Canada's Hudson Bay, the sea ice is breaking up about 3 weeks earlier than it did just 30 years ago. That's a much shorter hunting season. And the result? It's shocking. Male polar bears in that area weigh, on average, 67 kilograms. That's 150 pounds less than they used to. So, okay, the polar bear's struggle is this massive warning sign, but it's really just a symptom of a much, much bigger problem. Which gets us to the real question. What's the science behind all this? What is actually driving this global shift? Okay, to get what's happening, we need to talk about the basic physics that, keeps our planet from being a frozen rock. And the best way to think about it is like a blanket, a warming blanket for the Earth. And the key to this whole thing is something called the greenhouse effect. Now, this is a totally natural process, and honestly, it's essential. We need it. Certain gases in our atmosphere, they act just like a blanket, trapping heat and keeping the planet cozy enough for life to exist. So, how does this blanket actually work? Well, it's pretty straightforward. First, you've got sunlight, that high-energy stuff that comes through the atmosphere and warms up the ground. Then, the Earth tries to send that warmth back out into space, but as lower energy heat. And here's the key part. Instead of all that heat escaping, the greenhouse gases in the atmosphere grab a bunch of it and bounce it right back down, warming us up even more. And just to give you some perspective on how important this is, without this natural warming blanket, the average temperature on Earth would be a crazy negative 18 degrees Celsius. So yeah, the greenhouse effect itself, not the villain here. The problem is what we've been doing to it. We're making that blanket way, way too thick. Okay, so if this whole thing is natural, what's the big deal? What's different now? Well, this is where it gets really interesting. Scientists have figured out how to look back in time, and what they've found shows a really dramatic, really recent change. How do they do it? It's pretty amazing, actually. They drill these super deep cores out of ancient ice sheets, like in Antarctica. And trapped inside that ice are these tiny little air bubbles. You can think of them as perfect little time capsules of what the Earth's atmosphere was like hundreds of thousands of years ago. By analyzing the air in those bubbles, scientists can literally read the history of our atmosphere. And what they found was a really clear pattern. For at least 400,000 years, CO2 levels went up and down, but always in this predictable rhythm, kind of like the planet breathing with the ice ages. In this is where the story takes a sharp turn. For all those thousands and thousands of years, the CO2 level never went above 300 parts per million. Today, we're sitting at around 400. I mean, we have completely blown past the natural ceiling of that cycle. And there's no mystery about when this happened. You can pinpoint it. This crazy vertical spike in greenhouse gases. We're talking carbon dioxide, methane, nitrous oxide. It all kicks off right around the 1800s. It lines up perfectly with the Industrial Revolution and when we started burning fossil fuels on a massive scale. And look, this isn't just some abstract number on a graph. Making that planetary blanket thicker and thicker has very real, very measurable effects on the world all around us. So let's circle back to the Arctic for a second. If you compare the average summer sea ice from the late 20th century to the period between 2006 and 2012, it's a staggering 45% less. And get this, the 10 years with the least summer ice on record, they've all happened in the last decade. And it's not just the floating ice either. The oceans themselves are rising. Since 1870, global sea levels have gone up by 220 millimeters. That's about 9 inches. And that's happening for two big reasons. You've got all this water pouring in from melting glaciers and ice sheets on land, plus the simple physics that warmer water takes up more space. It expands. And those 9 inches might not sound like a lot, but they have a massive human cost. Just look at low-lying nations like the Maldives. Globally, something like 100 million people live on land that's less than a meter, about 3 feet above sea level. Their homes, their communities, their entire countries are at risk. So all these big physical changes, they're not happening in a vacuum. They're creating this huge domino effect that's cascading through entire ecosystems, messing up the delicate timing that species have relied on for, well, forever. Okay, let me give you a really specific example. Let's talk about a bird called the pied flycatcher over in the Netherlands. The survival of their baby chicks depends on one thing, and one thing only: hatching at the exact right moment when their favorite food, caterpillars, is at its absolute peak. So back in 1980, their timing was perfect. The chicks would hatch, and it was an all-you-can-eat caterpillar buffet. But today, warmer springs mean the caterpillars are peaking about 2 weeks earlier. And here's the kicker: the birds haven't caught up. They're still on their old schedule. So their chicks hatch, and the party's already over. They're literally starving, and in some spots, the population has plummeted by 90%. And this story, this timing mismatch, it's playing out all over the globe. In the oceans, you have corals getting so stressed by the warm water that they bleach and die. On land, pests like this insect called the hemlock woolly adelgid are surviving the warmer winters and just spreading like crazy. And maybe most worrying of all, up in the Arctic, the frozen ground, the permafrost, is thawing. And as it thaws, it releases huge amounts of methane, which is another really powerful greenhouse gas. And what does that do? It causes even more warming. It's a dangerous feedback loop, a vicious cycle that could start accelerating on its own. So, when you connect all the dots, the melting ice, the rising seas, the ecosystem's totally out of whack, a very clear picture starts to emerge. The evidence is just overwhelming. Our planet is in the middle of a rapid and, frankly, unprecedented transition. You know, the conversation is no longer about if this is happening. The real question now is, what comes next? How are we going to navigate the future that we are creating right now?